Hi students, good morning to all. Today we are going to discuss third chapter in first unit. The chapter is flow graphs and path testing. So in this concept, we have nearly five to six concepts are there. In that, we are going to discuss the first concept is path testing basics or basic concepts of path testing. So, path testing is the most important concept in software testing subject. So, such a path testing we are going to discuss here because for following concepts, what are the units or concepts we have? Most of them mainly depends upon this path testing. Such an important concept it is. So, in this concept, we have nearly seven sub concepts are there. So, in that, the first one is motivation and assumption, and second one is control flow graphs, and third one is path testing, and fourth one is loops, and fifth one multi-entry or multi-exit routines, and sixth one effectiveness of path testing, and seventh one is limitations. Among these seven sub-concepts in path testing basics, we are going to discuss one by one. In that series, in this video, we are going to discuss the first two concepts called motivations and control flow graphs. Among those two also, first we are going to discuss the point called motivation and assumptions. Before entering into the concept, we need to know what is that path testing. So path testing means path testing is the name given to a family of test techniques based on judiciously selecting a set of test paths through the program. So path testing means it is not a single test, it is a family of testing techniques. So there are different types of testing techniques are there in path testing. That's why we are saying path testing is the name given to a family of testing techniques, but they are based on selecting a set of test paths through the program. So all those test techniques are all we are applying on the paths, set of test paths. Well, what are the set of test paths we are selecting through the program? That is here through the program means so those test paths are developed with the help of programs. For example, just I will give the explanation description to you. If we have the program means the program is developed by a set of instructions. Here, each those instructions are developed in the form of control flow graphs or any graph manner. We have designed that one in a graph manner. Here, a graph means you can assume as a flow chart manner. In the flowchart manner we have developed that one, convert that one, first convert that one, that program used to the graph manners, and in the graph select the paths. For example, paths means if you come step by step, then if your decision condition is there, the condition is there. In the condition we have two paths, yes side and no side. Select first yes side, so that is one of the path, and come to the no side, that is another path. So select the paths and test the concept that comes under path testing. So the test path selection through only programs. So that is the concept of path testing, is the name given to a family of test techniques based on judicially selecting a set of test paths through the program. So path testing is performed by selecting set of paths through the program. So this is the concept of path testing. Then if the set of paths are properly chosen, then we have achieved some measures of test thoroughness. So if you select those paths properly, then you can get or achieve some measures of test thoroughness. So if you are not properly selected the paths, then you may not get the right result, of the test. If you selected the proper path, then you get correct answer of your test. Then, for example, pick enough paths to assure that every source statement have been executed at least once. So this is one of the most important concept point of path testing. So what is that means? You are picking enough paths to assure that every source statement have been executed at least once. So that means path testing is conducting through selecting the test paths. So when you are picking such manner, so you must pick enough path to assure. That means in the program, each and every statement wants to execute. That means test at least once. So you want to give the assurance of that, because if you does not execute any or does not test any statements, bugs may be hidden there. So that's why in the path testing you want to give confirmation. We test all the paths at least, or all the statements at least once. So this point is very important. Pick enough paths to assure that every source statement in the program has been executed at least one or tested at least once. So this is the important points in the concept of path testing. Then now come to the actual point, motivation and assumptions. In that first one, motivation. So which is motivated for path testing? Means path testing techniques are the oldest of all structural test techniques. So what are the structural? So generally we have two types of techniques. One is structural and another one is unstructural test techniques are there in that. So path testing techniques are the oldest of all structural test techniques. So path testing comes under structural. So in that structural also the path testing techniques are one of the oldest structural test technique. This path testing is most applicable to new softwares for unit testing. So path testing is more suitable and applicable for testing new softwares in the place of unit testing, not for total system testing. It is used for new softwares and used for only unit testing purpose. Then it requires complete knowledge of the program's structure. When you want to do path testing, you must have the complete knowledge of program's structure. The complete program structure you must clearly know. Then only you can do path testing. Otherwise, it is highly impossible to do path testing. So path testing is rarely, if ever, used for system testing. That's why I said already it's used for unit testing purpose. So it is rarely and ever used for system testing. To do large program testing, path testing is more complex. It is mainly used for testing unit testing purpose. So this is the main motivation concept of path testing. Then if you come to the second point, bug assumptions. Bug assumptions means how the bugs are assuming assumptions, how bugs are assumptions here. Then the bug assumptions for the path testing strategy is that something has gone wrong with the software that makes it take a different path than intended. That means in path testing, when you are testing the software, if something is going wrong in the software, so the path testing makes it to different path than intended. For example, before testing a program, we are intended some paths. So these are the paths we need to test. In that intended paths, if any problem is there, then if we need to change the path, we need to select the alternative path and find out whether this program is executing in a right manner or not. For that, a small example is there. As an example, go to X, where go to Y has been intended. So actually you want to go to in the path of Y, but they may contain some problem. That's why we are selecting the alternative path is nothing but X path. So in any way, you want to execute or test all the statements in the program at least once and find out the errors. That is the main motive of path testing. So this is the concept of bug assumptions. So main point is, so if something gone wrong with the software, that it makes it take a different path than intended. So that is the main point of bug assumption. Then this is the concept of motivation and assumptions. Then if you come to the second point, the second point in path testing basics is control flow graphs. So control flow graphs. So we know graphs means a pictorial representation of a concept. Flow graphs means so how the data is flowing. It is shown in the form of graph manner. Then control flow graphs means, so in the program we have control statements, how those control statements are flowing, the data in the control statements, how it is flowing, it is shown in the graph manner. So that is the concept of control flow graphs. So a control flow graph is a graphical representation of a program's control structure. So in the programs we have control structures, in that how the control is flowing, it is represented in the graphical manner. It's called control flow graph. So control flow graph is a graphical representation of program's control structure. So this is nothing but control flow graph. So it has means the control flow graph has some four different types of elements are there. They are named as, that means these four concepts are nothing but elements of control flow graphs. So the control flow graph uses the elements named as, one is process block, then second one is decisions, third one junctions, and fourth one is case statements. These are the four elements in control flow graphs. To design the control flow graphs, they using these elements. Those are nothing but process blocks, decisions, junctions, and case statements. With the help of these four elements, the control flow graphs are designing. The flow graph is similar to the earlier flow charts, with which it is not to be confused. So how the flow chart is look like? The flow chart, the control flow charts or flow graphs are look like similarly to the flow charts. So the flow graphs are similar to the flow charts. So for example, at the starting of the computer learning time, starting time of computer education, they give an example for flow charts. So before developing the program, the design of the program wants to develop, it's nothing but flow chart. Flow chart means the pictorial representation of our program. That flow chart, the flow graphs is also similar like flow charts. That's why it may not do any confusion for us. So now we are going to discuss these elements one by one. So first one is process block, how a process block wants to implement in the control flow graphs. For that, the process block is a sequence of program statements uninterrupted by either a decision or junction. So generally a process block is a sequence of program statements. For example, in our program, we have statements one by one, sequence of statements are there. Those statements are placed in, so generally we are saying statements. For example, int a comma b, then printf, like these types of statements so are placed in the process blocks. It does not interrupted by any decision or junction. So in the process block we may not have decisions or junctions. It contains only sequence of program statements. The statements are there. So the content of process blocks are nothing but sequence of statements. So the process block is a sequence of program statements uninterrupted by either a decision or junction. So it is a sequence of statements such that if any one of statement of the block is executed, then all statements thereof are executed. That means, so in that sequence of statements of the process block, if one of the statement is executed, then all the statements are thereof executed. So a continuous sequence statements must be placed in one process block. In that one of the statement is executed, then the continuation will be flow. All the statements in the block must be executed. So a process block means it stores continuous sequence of program statements. If one statement is executed, then all the other statements are also continuously executed. So that is the concept of this one. Then the next point is, formally, a process block is a piece of straight line code of one statement or hundreds of statements. That means in a process block, we can place one statement or hundreds of statements. But those statements must be sequenced. In between, there is no any junction, there is no any decisions. Those statements must be a sequence of statements. That is the main condition of process block. If one statement is executed, then the other continuation statements are also executed. Those statements may be one statement or hundreds of statements you can place in a process block. Then a process block has one entry and one exit. The process block may contain only one entry and one exit. The program does not jump into or out of the program. So in between, the program may not be jump into the process or may not come out of the process, because the process block may contain only one entry and only one exit. So that is shown here in the diagrammatic process. So a process is flowing, so it entering into the process block. So do process of A and it have only one exit. So this process block may contain one statement or sequence of number of statements may be there. So if one statement is executed, then other statements are also continuously executed and it have only one entry and one exit. So this is the concept of process block. Then the next concept is decisions. So what is mean by decisions here? Just simply in our flow chart we have statements, control statements, where while conditions, do while conditions, like that conditions are there. Those conditions here we are saying as decisions. So if a condition is executed, it have two ways. If the condition is true, it goes to yes way, or if the condition is false, it's move to no. So yes, no, two paths are there. So the same concept here we are discussed in the name of decisions. So what is meant by decision? A decision is a program point at which the control flow are diverged. So that's why I said, if the control is flowing sequentially one by one, if this decision is occurred, then based on the decision, if the decision is correct, then it goes to yes way. If the condition is wrong, it goes to no way. So two, in the flowchart we have a rhombus is there. Inside of the rhombus we have condition. If the condition is true, it goes in the true side. If the condition is false, it goes in the false side. The same thing we have discussed here in the place of decision. So decision is a program point at which the control flow can diverge. So yes, no, divergence are there. If the program control flow is diverged, it comes under decisions. Then most of the decisions are two ways. So most of the decisions are two ways. That means yes, no, two ways. But some are three ways branches in control flow. In control flow, other than two way, we have three ways also. Nothing but case statements. Case statements are more than two ways. So most of the decisions are two ways, but some statements are there. They have three-way branches also in control flows. So this is a simple diagram. So a decision is processing like that. So a decision enter the control flow is entering into the condition. The condition means we are representing in the flow chart as a rhombus. Instead of that we have the statement, if A is equal to B, then what? If the statement is right, it goes to S way. Otherwise, if the condition is false, then it goes to no way. So wherever the statement flow is there, if the decision is there, it diverts the flow. It diverts into two ways, either in yes or no. So this is the concept of decision. Then goes to the third control flow statement is case statements, continuation of your decision. So what is this case statement says? A case statement is a multi-way branch or decision. So already we said two ways means decision. Multi, more than two is there means it comes under case statement. So case statement is a multi-way branch or decision. So case statements is also comes under decisions. So it is a multi-way branch. For example of case statements are a jump table in assembly language and the Pascal case statements. So example for case statements are jump tables in assembly language. That means we are saying ALP language, assembly language, and in the Pascal case statements. From the point of view of test design, there are no difference between decisions and case statements. For the test designing point of view, the test design point of view, they are not showing any difference between decisions and case statements. Decisions may have two ways, case statements may have more than two ways. So that is the only difference. So when designing the tests, it may not show any difference between decision and case statements. So how case statement will be look like? Just the flow is entering into here and a condition, a case is there. For example, in our Java, we have case statements, switch statements are there. Those switch statements here we are saying as case statements. So your flow is first entering into the case of. So after the case is executed, then we want to go to case 1. If the case 1 is true, it gives the case 1 answer. Otherwise, if the case 1 is not satisfied, then goes to case 2. If case 2 is okay, then it gives case two's answer. If case 2 is also not satisfied, then it again goes to case 3. So this is the concept of case statements, and this is the pictorial representation of case statements. So a flow is entered, if a case is occurred, if this one may satisfy to any one of these cases. If which case is satisfied, then other cases may not be executed. Simply switch statement in our object-oriented programming languages or in C language. The same here we are discussing the name of case statements. Then if you come to the fourth one, junctions. So what is meant by a junction? A junction is a point in the program where the control flow can merge. So, for example, there is a small difference between junction and decision. Junction means it is in the program point of view, the control where the control flow can merge. It comes under junction. Where the control flow is diverge, it comes under decision. That is the only difference between junction and decision. So decision means the control flow is diverge. Junction means the control flow is merged, where the control flow is merged. So that point we are saying as junctions, where in which point the control flow is diverged. It's called as decisions. Where the control flow is merged, it's called as junction. So junction is a point in the program where the control flow can merge. So example for junctions. Example of junctions are the target of a jump or skip instructions in ALP. So in the main most important example for junctions are jump or skip statements in ALP or a label, that is a target of go to. So in our programs we are using go to statements. Those statements are all comes under examples for junctions. Then the pictorial representation of junction. So the flow is there, then another flow. So maybe come from somewhere. So if two flows are combined in a a point. So then that point will be called as junction. Then after merged, then again the flow is going on. So into that some other flow is also combined in the point node 2. So there node 2 is also a junction point. So these are nothing but junctions where the flows, control flows are merged. So this is comes under junction. So node 1 and node 2 are junctions. If divergence are there, it's called as decisions. So this is the concept of junctions. These are the four elements of control flow graphs. One is process block, and second one is decision, and third one is case statements, and fourth one is junctions. So these are the four different elements of control flow graphs. Then what is the difference between control flow graph and flow charts? Control flow graph versus flow chart. So first one, a program's flow chart resembles a control flow graph. So program's flow chart may resembles control flow graph. Maybe both may be similar format. The flow chart is similar to control flow graph. That's why we are saying program's flow chart resembles a control flow graph. In flow graphs, we do not show the details of what is in a process block. So in the flow chart, so what is the content of process block? We are not giving any details about that. But in the flow chart, every part of the process block is drawn. That means if you take the flow chart, each process block wants to design detailedly. But in flow graphs, we are not providing that much of details for the process block. That is the main difference. So process block wants to design detailedly. But in the flow graphs, we may not show the details of the process block. The flowchart focuses on process steps, whereas the flow graph focuses on control flow of the program. Flowcharts are mainly focuses on process steps. So flowchart mainly focuses on process steps, but the flow graph mainly focuses on flow control flow of the program. So flow graphs are mainly concentration on mainly showing or focusing on control flow of the program, but flow charts are focuses on process steps. So this is the main difference of flow charts and flow graphs. So the act of drawing a control flow graph is a useful tool that can help us clarify the control flow and data flow issues. So with the help of control flow graphs, it mainly gives the clarity on how the controls are flowing and how the data is flowing. So it gives the clarity on those two concepts issues. So these are the main concepts differences between control flow graph and flow charts. So for example, just take an example, program example. So generally in our program development, a program statement is given for us. First we need to develop flow charts. Afterwards we need to develop program. But for the sake of your understanding, just I taken the program first. If you assume this is the program, for this program, how the control flow graphs are designing. So for this program, first before developing the control flow graph, we are going to develop flow chart. So these are the statements. Just once go through these statements. These are the statements in the program. Just I am giving an example to you how the flow graphs are designing from the program, because we are selecting the paths for testing. For path testing, we are selecting the test path through the program. So that program is this. So through this program, how we are taking the paths for testing with the help of control programs. That is the concept. For that, we are discussing all these points. For that, just take an example of programs and go through all the statements once. So with the help of these statements, how a control first a flow chart is designing. just go through a few lines. Code input x comma y, z is equal to x plus y, b is equal to x minus y. If z greater than 0, go to SAM. That means this statement. Otherwise, go to JOE, this statement like that. So remember these lines, at least these lines, we will discuss that one in flowchart. So now this program is now converting into flowchart first. So this is nothing but one-to-one flowchart. So flowchart is always developed in a vertical manner, but due to space problem, I developed in the horizontal manner. So in the program, we discuss some points: input x comma y. So input is also one of the process. So we placed detailedly in the process block. Okay, then z is equal to x plus y, it is also one of the process. Then b is equal to x minus y, it is one of the process. And z greater than 0, this is condition. That's why I placed in this one. If the condition is yes, go to SAM, otherwise no, JOE. So that is the 4 or 5 statements we discussed in the program. So it is developed in this manner. In the same manner, total flowchart is also developed. But to discuss all these things, it may take more time. That's why I taken few lines. So in this manner, the flowchart is designed for the program. So how the control flow graph? So it is also just look like in the same manner of flowchart. But what is the difference between them? So there we have at the starting 3 statements are there: input, x plus y, x minus y. So in the flowchart, all the processings must be detailedly shown, but in the flow graphs, we need not to show that much of details in the process block. So all those 3 sequenced process statements or program statements are placed in one process. So this process may contain now 3 statements: input x comma y and x plus y and x minus y. All these 3 statements there we shown detail in flowchart, but in flow graphs we placed in a single process. Then condition is there: yes, go to SAM, no, go to JOE. So same process, but we reduced. So that means how we are reducing means what are the sequence processing statements are there. Those all the sequence process statements are placed in one process block. Other things are all same. So if we do like that, then the large flow chart is now converted into somewhat simplified flow graphs. So we can again simplify this one. Just go through it. Statements are there, conditions are there. If the condition is there, we have 2 paths. The same manner, we can more simplify the control flow charts like this. Simplified flow graph notation example. In this manner, we can simplify that control flow charts. So begin this node 1 means nothing but process 1. Then after complete the process, it goes to node 3. Node 3 is a condition. If the condition is executed from this node, we have 2 paths. One, you may go to SAM or you may go to JOE. So this node 4 is nothing but a JOE concept. Like this, that control flow graph is now converted into a simplified control flow notations. So all the statements are there, but we are simplified here. That's all. So this is one of the simplified flow graph notations. So here, what is these nodes and what is these links? Everything we will discuss in the diagram description area. So in the diagram description, the circles are there with more than one arcs. Leaving is decision. So circles are there. Those circles we are saying as nodes. From those circles, if more than one arcs means links, arrows are leaving. So such circle will be called as decisions. That's why we already discussed. If the links are diverged, they are comes under decision. So from the circle, more than one arrow is leaving, it comes under decision. Then a circle with more than one arrow entering is junction. So for a circle, if more than one arrow is entering into the circle, so that point will act as a junction. If diverging, leaving is there, or diverging is there, it comes under decision. If merging is there or one or more arrows are come into that circle or node, called as junction. Then we call circles as nodes and arrows as links. So the circles will be called as nodes and the arrows are called as links. Nodes are usually numbered or labeled by using the original program labels. So nodes, that means our circles, are named as number. Either you can represent the node as number or labels by using the original program labels. So whatever the conditions or labels we have in the original program, we can name like that, or we can name by numbers. So this is the description of that simplified flow notation. So in this video we discussed 2 points. One is motivation and assumption, and second one is control flow graphs. Thank you.